Hello, welcome back to Pre-Algebra with Miss Betsy. Today we are discussing multiples and factors. Now if you happen to be using the first edition of Pre-Algebra for Christian Schools by Bob Jones University Press, this corresponds to section 5.1 on page 145 of your text. That once again, as always with Pre-Algebra, this material translates well to any textbook that you're using. Before we get started, I've got a couple of riddles for today. What do you call a man who doesn't have all of his fingers on one hand? Well, you would call him normal because you have fingers on both of your hands. And then, how many letters are there in the alphabet? And yes, I'm talking about our American English alphabet. Well, there are 11. T-H-E-A-L-P-H-A-B-E-T. So there are 11 letters in the two words together that say the alphabet. So let's go ahead and look at our math for today. This is just basically some definitions that we're talking about. First, we're talking about what multiples are. A multiple is the product of a number of that particular number and any whole number. Particular number and any whole number. Has to be a whole number. Remember, whole numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Also 0, but we're not going to consider 0 when we're talking about multiples of a number. So a multiple is the product of that number and any whole number. You think of multiples as when I say count by 2s, 2, 4, 6, 8, 10, count by 5s, 5, 10, 15, 20. What you're doing with multiples is you're taking that number and you're multiplying it by any whole number. So if I were to ask you, give me the first 4 multiples, and of course I write a 4 instead of a 3, because that's what comes out of my mouth. 2 times 3 is 6. 2 times 2 is 4. 2 times 1 is 2. 2 times 4 is 8. Your question asked you to indicate the first 4 non-zero multiples of 2. This is what we have here, and you would show your answer 2, 4, 6, and 8, and then you would circle it or square it off. So all multiples are the product of whole numbers, typically in sequence, with one particular number that's repeated over and over. Now they're typically going to want to indicate non-zero multiples. Why is that? Because remember that from our zero property of multiplication, it doesn't matter what we multiply by 1, 0, by 0. What does our answer always equal? When you multiply anything by 0, the solution to that, or the answer to that, is always 0. So it doesn't do us any good to say, give me the first 5 multiples of 2, and say 0, 2, 4. Because the 0 multiple of any number is always going to be 0. So if it asks you to give us the first 4 multiples of 7, they're really asking you simply to count by 7s. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4, and there I go again, writing the 4, 7 times 4 is 28. So those would be the first 4 non-zero multiples of 7. And on some sort of a standardized test, they might give you a sequence of numbers, multiples of 7. And they might say, okay, you have these numbers here, 7, 4, 21, 28. What comes next? Now they're not going to ask you that in this test, in your text, but this is what they're building on. You're recognizing a pattern. This is 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. So the next number in your pattern is going to be a 35. This is all we're talking about with multiples. It's the product of a particular number and any whole number. And now, I just mentioned product. What is a product? A product is the answer to a multiplication problem. What are the numbers that you multiply together to get a product? Well, those are called factors. So the product is an answer to a multiplication problem. And factors are the numbers that you multiply together to arrive at that answer. And there are a number of combinations of factors that you can use at times to come up with the same number. And this is what we're going to be looking at. We're going to be finding all of the possible factors of a particular number. Now, what is the answer to 2 times 3 times 4 times 5? Well, 2 times 3 is 6 times 4 is 24 times 5 is 120. But did I actually look at that number and say 2 times 3 times 4 times 5 and know that that's 120 just by lumping all of those numbers together? Well, no, I didn't. Now, I happen to know that when you multiply those first four numbers together, it's 120. And if I didn't, though, I would be very easy to arrive at the answer, because our rule for multiplication for order of operation says when you have multiplication or division in one mathematical expression that you multiply in order from left to right. 2 times 3 is 6, then I have 6 times 4 times 5. 6 times 4 is 24 times 5. 24 times 5 is 120. Now, how did I arrive at that? Did I multiply all of those numbers together? I say you get a free laugh on that when I just got a text from my friend who's in the Texas Panhandle. So she's just checking up on me. 2 times 3 times 4 times 5. Well, first we multiply just 2 digits together to get the 6. Then multiply 2 digits together, 2 more digits together. So when you have factors, you can only multiply 2 numbers together at one time. Now, if you have a question and it says, is, for example, 3 a factor of 21? What is a factor? Factors are numbers that you multiply together to get the product. So you can divide. You divide 21 by 3. This is just a simple multiplication fact that you should know. 7 times 3 is 21. 3 is a factor of 7 because you can take 3 and multiply it by 7 to get 21. 3 is a factor, 7 is a factor, 21 is your product. So this has to do with the vocabulary, with understanding vocabulary. Now, let's say that they ask you to list all of the factors of a particular number, 21. What 2 numbers can you multiply together to get 21? Well, we already know 3 times 7 is 21. And of course, 1 times 21 is 21. So if we wanted to list all factors of 21, you would list them in order: 1, 3, 7, and 21. And that would be your solution. Not that 1 times 3 times 7 is 21, 21 times... No, but that we have pairs of factors here, pairs of numbers here, that when you multiply them together, you arrive at 21. Now here, you only have 4 possible numbers that pair up together to equal 21. Well, what if we had 18? We said list all the factors of 18. Well, how can you form 18 by multiplying 2 numbers together? 1 times 18, 2 times 9, 3 times 6, 4 times nothing, 5, 6 times 3. These are the same, aren't they? We're using the same factors here, so we don't need to repeat those. Remember that multiplication is commutative. So we have 3 pairs of factors that we can multiply together to arrive at 15, at 18 rather. We would list them in order: 1, 2, 3, 6, 9, 18. And that would be how we would list all of the factors of 18. That's all that you're going to be doing in section 5.1. Enjoy yourselves, and I'll see you next time.